Okay, today we're going to go through 6.7 recursively defined sequences. Okay, and so we went through the sequence yesterday where we had geometric sequence. We've already dealt with arithmetic sequence. Remember, arithmetic is where you're adding, geometric is where you're multiplying. You have that common ratio of R when you're multiplying, you get the common difference of D when you're adding. The recursive formula that you're dealing with, the recursive formula is just a way of saying, hey, the next term in my sequence is this. So if I gave you the sequence, for instance, 2, 4, 6, 8, and so on, and I wanted to say, well, first of all, I know this is A sub 1, A sub 2, A sub 3, A sub 4. If I wanted to know what A sub 5 is, if I wanted to know what A sub 5 is, most of you would just say, well, I'm going to add 2 more and I'm going to get 10. Right? Like that's the easy way to do it. Okay? The recursive formula says, well, if I want to know A sub 5, I could take A sub n minus 1. Well, if A sub 5, if n is 5, what's n minus 1? What is it? 4. Yeah, it's 4. So I would take A sub 4, and I would add my common difference, which in this case is 2. I'm going up by 2 every time. So the recursive formula really is just a way of saying what you already know in a very easy way. Okay? So this would be A sub 5 is equal to A sub 4, which is 8 plus 2. Hey. That one. Thank you. So we get 10. Everything should be saved on there. All right? That seems like a long way to when you could just say plus 2, right? And get 10. All right, but that's what the recursive formula is. It's the formula you rarely use because you just do it mentally. All right. So the question I would have if I were you is like, why would I want to even know that formula? Okay? So, well, hopefully you don't use the formula when you're doing it mentally. But what we're going to do is we're going to kind of apply that in our extra practice here. So take a look at page 201. Sure. You're going to miss some of the instructions. Okay, number 1. Write the first 6 terms of the sequence and graph the sequence. Okay, talk to your neighbor. Tell them what the first 6 terms are going to be. Before we get to graphing, did everyone find the first 6 terms? No? Did anyone find the first term? Yeah, what's the first term? Negative 2. Yeah, A sub 1, right? So why do we need to know the recursive formula? Because they just put this in the recursive formula. Which of those 2 formulas that we just looked at on the previous page, which one are we dealing with here? Think geometric? Okay, how many say geometric? Arithmetic? How many have no idea? Okay, do you see an addition symbol? No? Do you see a multiplication symbol? Yeah, so which one is it? Geometric, man. Okay, we're dealing with geometric. Notice you have a to the n minus 1 power, or a sub n minus 1. That's right here. And we have negative 2. What's unique about that negative 2? Like, what's important about this? It's R. And R tells you what you are doing what by? What you're multiplying by. That's a key thing, man, because that tells us our next term, which is? 4. And then? Whew, just in time, man. Wow, that's close. All right, so graph it now. Talk to your neighbor about what your scale is going to be, where you're going to put your axes, all that cool stuff. Well, here's what I know. I think on the x-axis, I'm going to go by ones. How come? Because remember, when I'm graphing a sequence, I'm really just graphing the first, second, third, fourth, fifth, sixth. Okay, that is the top of my table. Just what number in the sequence I'm dealing with. Your a sub n. So really, I only need to go out to 6 here. 1, 2, 3, 4, 5, 6, 7. Dude, I'm perfect, man. However, I have to have as low as -2 and as high as, as low as -32 and as high as 64. So I cannot go by ones here. Could I go by 2s? 3s? 4s? What should I go up by?
I went up by 20s.
By 20s? Hey, that helps me out. Okay, there's my 20s. Yeah, I don't get -32 though. That's not good. Could go by 8. But we won't get, will we get 64? If we move where the axis is, right? We could. Yeah. Okay, so it just depends where you put your x and y axis. Why don't they define the axes for you? Because you need to learn how to do this. So it's going to depend where you put your x and a y to make your graph. Okay? And then you're going to have to figure out what to go up by on the y-axis. I'm going to leave that to you. You guys can do it. This won't work right here, what I have, because it doesn't go down to -32. Okay? Yeah. Oh, -10? Oh, so now it would work. And why is Mercedes the only one that caught that? So you're not smart? You're smart. All right. Hey, now it will work. Dude, if we count right. Would -8 work? Jilly said -8. Or going up by 8. Yeah, if you move your x-axis up, it works. Okay? It may be a good number because -8 goes into all of these, except for 4. Okay? So you can use whatever you want. You just have to make sure that you're putting the lines or your axes in the correct spot. Okay? Very good. All right, I've got this one actually already graphed here, so you can check it out. That's what it is. I'm not going to show you the other one. Not even that one. Whew. All right. Hey, any questions there? Dude, Saved by the Bell again. That's a close one. All right, whenever we try number 4. Give it a go. Hey, is this one geometric or arithmetic? Arithmetic. We have our -4 there. That is our common difference. So our first term is 14. We're going down by 4 each time, so we get 10. Well done. Okay, once again, to build our table, all we're doing is, Kirchhoff style, okay, what'd you guys go up by? Okay, someone tell me where they put their x-axis. Tell me when to stop with my pen. Right there? Yeah. All right. Y-axis? Going a lot faster. Right there? Okay. What are we going up by on x? Okay. What are we going up by on y? Sorry, couldn't resist. That's so good. So you went up by 2? Okay. Anyone else go up by 2? Anyone go up by 3s? Anyone go up by 1s? No one went up by 1, so that's good. Anyone go up by 5s? Good. That's what I went up by the way. All right. So 3s. Anyway, no matter what you do, let me show you what I've got. Okay, I went up by 5s, but it doesn't matter. Okay, as long as it works out. Probably wouldn't go any higher than 5. 3s probably would have been the best scale there. There, you got it. Nice job. Okay. Okay, take a look at number 7. Lucky number 7. Go ahead and give it a go with your groupie there. Okay, Kai, what do you think? Recursive, is it geometric or arithmetic? Geometric, how come? Because what? It is multiplying by what? By 1/3? Everyone agree? All right. Okay, so what's our equation then? Sure. Okay. A sub n minus 1. All right, we're using our recursive formula again, once again. So once we figure it out, we plug it in. For r, we have our a sub n. Well done. Not sure I get that. It's the same thing but different.
It does the same thing, but it's a different...
No, hey guys, the recursive formula just tells you the next term. The explicit formula allows you to pick a term in the future. Like, here's this, the 4th term. If we want the 5th term, we could use this. Or just multiply by 1/3. If we want the 105th term, we'd want to use the explicit formula. Okay, remember the explicit formula is where we had a sub n is equal to a sub 1 times r to the n minus 1 power. Okay, that was the formula we used to find a term way down the road. Okay, 2 different formulas. All right, we're not using this one right now. All right, Sebastian, you all right? Yeah? Tired? Should I call home? Say, hey, Sebastian needs an early bedtime, man. He's really sleeping in class. Like he's leaning back. He might fall back and hit his noggin, and then he'd be sleeping really in class. That would be bad. Don't want that. That would be bad. All right, number 9. Give it a go. Hey, good question. Is a recursive rule the same as a recursive equation? The answer is yes. You're just multiplying by 1/5 every time here. Therefore, you've got your a sub n is equal to you could have put your parentheses around the 1/5 instead of the a of n minus 1, but either way. Okay? All right, so on 10 and 11, on either of those, is this arithmetic or geometric on 10? How about 11? Arithmetic, so you got to use your other formula. Okay. Any questions? Give number 14 a go, please. Number 14. Okay. Hey, it might be helpful to remember the explicit rules. We just talked about one of them. Hey, the explicit rule for a geometric sequence. A sub n is equal to? No, let's ignore this. Just in general terms, what's the explicit rule? A sub 1. Okay? That's the explicit rule. Remember, explicit means when you're going later in the future. You want one of those numbers later down the road. How about, that's for geometric, how about for arithmetic? You always start with a sub 1. But with arithmetic, what are you doing? You're adding.
Minus 1.
Times d. Okay, we haven't done that one for a while, but there they are. Those are your explicits. Note the difference between explicit and recursive. Okay? You don't need to phone your friend or text your friend to get it. Some of you are doing that right now. You're like, dude. In math, I know you're in English, but could you give me the explicit rule? Don't need to do it. All right? So number 14, they give you a recursive. Is this geometric or arithmetic? Geometric. So R is? R is 3. So now we need to write the explicit rule, which is right here. So A sub n is equal to? There, we've got it. Piece of cake, man.
I like cake.
Yeah, good stuff. Okay, so we're using our explicit here.
Too bad. That's a fun game, though.
Okay, 17 to 19. Take a look at 17. Write a recursive rule for the explicit rule. So now it's in explicit format. Is this recursive, or excuse me, is this geometric or arithmetic? Tyler, geometric or arithmetic? How do you know? Because it's adding, yeah. So we're going to take this, which we have, we know that this is our explicit, so we're going to take our explicit, which is in this format. The problem with what they've given us here is they've already simplified the equation. Like, they don't have all these other pieces that are in the original explicit. So you need to, let's go ahead and simplify this explicit form. A sub 1 plus, let's distribute here. That would give you dn minus, just minus d. Okay? So really what's important to us, if we put it in like slope-intercept form, I know this looks really weird, but what's important to us is this thing right here. The number that's attached to the end is our what? It's our d. So our common difference now is 6. That is our common difference. Okay? So if we're writing our explicit rule, we have A sub n is equal to A sub n minus 1 plus 6, our difference. Where'd what 2 come from? This 2 would be those two things combined. Hey, dude, your assignment is your extra practice. Finish up those 2 pages. Number 20 through 22, you can kind of just look for the pattern right now. Okay?
So we have to do
Finish page 201 and 202.